E ngā iwi, e ngā mana, e ngā hoa mahi, tēnā koto katoa. E mihi ana ki a koutou, kua tae mai ki te tautoko tēnei kaupapa. Ngā mihi nui ki a Sergey Paltsev, te kaikororo o te rā. Tēnā koe, Sergey. Nau mai haere mai ki te tae ohanga, ko Tim Ing ahau. Good morning, everyone. I'm Tim Ing. I'm a Strategic Economic Advisor here at the Treasury, and I'm very pleased to welcome you to our guest lecture today. We're delighted to host today's event jointly with Motu Research. Many thanks to Motu for working with us together to bring this event to you and to support informed debate on some of New Zealand's most pressing economic challenges. I'm especially happy to welcome Dr. Sergey Paltsev from MIT, our distinguished speaker for today, and who I will introduce more fully shortly. In the meantime, welcome, Sergey. It's great to have you with us, and thank you for taking the time and for sharing your experience and expertise with us today. For those of us in the room, let me please start with a quick briefing on health and safety and emergency for everyone. Bathrooms can be found to the left-hand side of the kitchenette. Please walk straight ahead after exiting the rooms. In the event of a fire alarm, please follow Treasury staff to the nearest exit and go down the stairwell to evacuate the building. Please don't use the lifts. In the event of an earthquake, please drop cover and hold and stay in the building until instructed by a warden. So once again, welcome everyone. It's wonderful to see everyone here and online. So this seminar is one of several we're presenting under the theme of productivity in a changing world. This theme recognises that significant global trends such as climate change, population ageing and technological innovation are reinforcing the importance of lifting New Zealand's productivity performance and creating new challenges for productivity along the way. All our speakers in this series have kindly agreed to share their expertise on the implications of these trends for New Zealand's economic and productivity performance and for the sustainability and resilience of the economy. So, as promised, let me now introduce more comprehensively Dr. Sergey Paltsev. He's our speaker for today, and we're thrilled to have you with us. Sergey is the Deputy Director of the Joint Programme on the Science and Policy of Global Change at the MIT, Massachusetts Institute of Technology in Cambridge, US. He's also a Senior Research Scientist at the MIT Energy Initiative and MIT Centre for Energy and Environmental Policy Research, and a Director of the MIT Energy at Scale Centre. Sergey is the lead modeller in charge of the MIT Economic Projection and Policy Analysis Model of the World Economy. His research covers a wide range of topics, including energy economics, climate policy, taxation, advanced energy technologies, and international trade. He was a lead author of the fifth assessment report of the IPCC, the Intergovernmental Panel on Climate Change. Today, Sergey will share findings from the recently released MIT Global Change Outlook, which provides analysis of the risks and benefits associated with existing climate policies. The outlook emphasizes the need for faster action to stabilize the climate and to protect human population and natural systems. Sergey will look at the case for hydrogen-based fuels and renewable natural gas, using studies of selected industries. He will also discuss the role of government in realizing the potential of hydrogen-based solutions. This is obviously a very topical issue both for New Zealand and for the rest of the world. We hope that you will find Sergey's presentation and the report findings useful analysis to support the many complex decisions needed in both the public and private sectors to transition to a low emissions economy. In a second, I'll invite Sergey to take the floor. After his presentation, we'll have time for questions, both from the room and from our online audience. For online folks, we'll monitor for questions in the Q&A functions on Teams. You'll see that at the row of icons at the top. So please feel free to post your questions in the Q&A there at any time. If you have any technical queries or feedback like connectivity issues, please use the chat function. So let me now hand over to Sergey, and once again, welcome.
Well, Tim, thank you for such a wonderful introduction. First of all, I'm not going to tell anything about the New Zealand economy, so just to make sure that you don't have false expectations. If you have any questions about the New Zealand economy, I can suggest one of my best colleagues, Niven Winchester, who is sitting here and who actually organized this. He's a professor at the Auckland University of Technology. He has spent 10 years at our program at MIT, and now he's doing a lot of analysis for New Zealand. But I'll plant here and there kind of couple of the facts which I know about the New Zealand economy. And so kind of let's see where that is going to lead us. Also, I'm from academic institution, and so it means that I love questions, right? So if I'm going to lecture you for 3 hours and I have no questions, I'll be bored, right? So it means that if at any point of the presentation you have any question, raise your hand and interrupt me at any point and let's have a discussion. Because, well, I know what I'm going to tell you, right? So I have no interest in that because, well, that's not a new information for me. What I'm really interested in is to see your reaction, right? So see your skepticism, see your optimism, because that is going to guide me, okay, where you are in all these topics. So a couple of the things which we are going to cover today, and again, whether you like it or not, you're mine for the next 40 minutes. So I'm going to talk to you for the next 40 minutes, and then you're going to give me a hard time after the hour. But even in between, also feel free to ask those questions. So I'm going to focus on a couple of the things, and you will see that our program is doing a lot of different research in different areas. And again, I briefly touch on some of them. But most of the focus is going to be on two topics. Well, one, obviously hydrogen, because, well, that's in the title of the presentation. And we are going to talk about different colors of hydrogen and all things which are related to that. And also, I'm going to put that into the perspective of our global change outlook. So you will see some of our results, and I'll explain you what that outlook and what we do and how we do that. So those are the two main things, but again, you will see that we are covering many other things. And so if you will, in passing, see something of interest, then later on in Q&A, we can explore other topics which are not directly related to those two items. So let's start right away and kind of again to the topic of hydrogen. Well, many of you know that, well, hydrogen has many, many colors. Well, in fact, it's colorless gas. So in the reality, it has no color. But there are many colors when people are describing what hydrogen is. And obviously, everybody knows, right, including everybody in this room, that we love the green color, right? So green color, green hydrogen is something which is good. And fossil fuel hydrogen, it's okay, but not as good, right? Well, the reality is a little bit more complicated than that, and we will go into kind of different aspects. But kind of couple of the colors, if you're not familiar with this rainbow yet, so a couple of the colors to keep in mind. So green hydrogen is electrolytic hydrogen. And why it's good? Because you can produce it through electrolysis of water. And for that, you're using wind and solar. So in principle, all renewable energy, no emissions. And so as a result, well, kind of from emission point of view, well, that's a very attractive pathway. But that's not the only low carbon hydrogen. So there is a term LCI, and later on I'll expand into that. So in my home country, in the United States, there is something which is called IRA, right? It has nothing to do with Ireland or Army. So IRA stands for Inflation Reduction Act. And so Inflation Reduction Act actually is providing some subsidies to certain low carbon hydrogen pathways. And so again, we are going to talk a little bit about that. And so those of you who are involved in hydrogen a little bit more intimately know all these abbreviations, 45Q, 45V, and so those are the particular section of the tax code from the United States, which gives certain subsidy to different type of the hydrogen. And so speaking of the green hydrogen, for example, well, the subsidy is $3 per kilogram of hydrogen. Later on, I'll orient you, well, is that lot or not lot? So what is that $3? But if we are talking about blue hydrogen, the next one on this slide, which is basically fossil fuel based, but with carbon capture. It also provides the low carbon alternative, but that, because it has higher carbon intensity, that gets the subsidy of only 60 cents. So again, you can see that, well, you still kind of go into different pathways and get different type of the subsidy, but there is some trade-off between the emission intensity and cost and the subsidy, which at least how it's currently specified in the United States. But currently, hydrogen is not produced. Well, a little bit of green, very, very, very tiny, and little bit of blue, again, very, very, very tiny, but most of the hydrogen is actually so-called gray hydrogen. What that means, it means that that hydrogen is produced from fossil fuels, and the main avenue in most of the parts of the world, that hydrogen is produced from natural gas. So there is steam methane reforming, where you're taking natural gas, right, methane, CH4, and you're taking that hydrogen out of that CH4, and kind of you're producing your hydrogen. Well, there are different pathways. There's autothermal reforming. You can do gold gasification. You can do biomass gasification. Well, that is actually doesn't have a color, surprisingly enough. But again, the point is it's fossil fuel based. So the gray hydrogen, yeah, you can produce hydrogen, but the emissions in the production are quite sizable. And so that's why kind of, well, we don't really want to go that pathway if the goal is to reduce emissions. But also there are other pathways which are a little bit less explored, but also you can produce hydrogen from nuclear power, so that pink, right? So you can do pyrolysis, kind of where you're producing hydrogen, but also carbon black, kind of the solid substance, which if you know how to use later on, or if you'll find the way how to use later on, and we can talk a little bit about that byproduct and where that can be used, well, that's another pathway. And obviously there is white hydrogen, so that gets more and more attention, which, well, that white hydrogen is like natural hydrogen in natural forms. And why we are talking about that? Because recently it was a couple discoveries where people were drilling for other things, well, natural gas or something else, and they found hydrogen. And they said, oh, okay, yeah. But the point is, we don't really know where to look. We don't really know kind of what's the economics. But in principle, and you can even, well, under certain conditions, you actually can do and kind of do that geologic production of hydrogen and get it back. Still, that is very, very far from the economics and very, very far. But, well, that's another form of hydrogen. So hopefully by this time now, you're all experts in different colors, right? Remember, green is good. Blue is kind of good. Everything else is not so good. Well, pink if you like nuclear, but when I took a taxi from the Wellington airport, the first sign is saying, welcome to Wellington, nuclear-free town, right? So let's not talk about that here. Okay, coming back to hydrogen regions, why people think that hydrogen might be a good solution? And well, here's the slide which kind of tries to summarize and kind of try to kind of make sure that we know all the story. Well, one big benefit is that it can be a solution for many parts of the economy. In fact, it can be a solution for all of the energy needs in different parts of the economy, not just in electricity, not just in industry, but also in transportation, residential, commercial, in remote locations. So there are a lot of potential where hydrogen can provide that low carbon solution. And you can store it in different forms. You can see that, well, it can be gaseous form, it can be liquid hydrogen, kind of you can do a lot of different things. But the point is, hydrogen is like electricity, right? So electricity, you need to produce it. Electricity is not an energy source, it's energy carrier, right? So we are producing and then we carry energy by the amount of energy and some losses which we put into the production. Hydrogen, more or less, is the same story. Hydrogen is not energy source. Hydrogen is energy carrier. We have to produce hydrogen first in order to use it later. And so as a result, well, hydrogen does not emit anything, but whatever the process is used to produce hydrogen, well, that is going to determine its environmental implications. So again, if we are going to use a lot of natural gas and with all of methane leakage and other things, well, then the story with hydrogen is not as attractive. But if we are using wind and solar, then hydrogen is very attractive fuel in terms of the environmental implications. And also with everything, well, there is not a single solution where, well, we don't have the trade-off. So kind of there is no silver bullet, which kind of in terms of the energy which we can use and do not have any challenges with that. So similarly with hydrogen, we have many, many challenges. And again, kind of the first point, we don't really have a hydrogen economy. So in principle, it can be solutions for many, many sectors, but we need to scale up infrastructure for that. And that infrastructure is non-existent, more or less. And so the point is, yes, that scaling up is going to be a big problem. And when we are going to talk about transportation use, well, that's one of the major problems. And that's one of the major reasons why, for example, in personal transportation, electric cars are winning over hydrogen or plug-in hybrid fuel cell vehicles. And we will discuss why. Why is that? What's the reason? Also, as we will see later on, hydrogen is expensive fuel. It's not cheap. And I'll provide you some of the categorization. What do I mean by expensive fuel? And it means that, yes, in terms of the emissions, that might be a very good solution for the economy, but you need to be ready to pay a lot of money for that. And so it really depends on, well, the government support, about the acceptance, about the willingness to pay that money, if that solution is going to be the reality. And I remember one of my first presentations on this topic about 5 years ago, and I obviously, well, at least when I was thinking about hydrogen at that point, I already had a picture of Zeppelin, right? So you remember that, and Hindenburg, right? And all these things, and I put that picture on the slide, and then after the talk, I got somebody from one hydrogen-based company. I don't think it's a good idea to put something like that when you're talking about hydrogen. So you see that I have much more positive picture. So I'm learning, I'm getting there, right? So, but it's still an issue. So safety is obviously is important. Okay, so well, why again we are talking about the hydrogen? Whenever we are dealing with less informed public, less informed policymakers, the immediate reaction, oh, haven't you heard? The cost of solar, the cost of wind is so cheap. Why don't we just go to wind and solar? Why do we need all these other things? And well, probably in this country, you know why we are not going 100% wind and solar. And kind of, well, there are some reasons for that. But in many places, well, there is that perception from the public. Well, solar is already super cheap. Why do we deal with all these other energies? So in other words, well, there is this kind of proposal. Okay, let's electrify everything and let's decarbonize electricity, and then problem solved. The issue is, well, there are some challenges with electrify everything. Well, there are also issues with decarbonized electricity, but that's, I think, a little bit less challenging. But electrify everything, and I list here some of the examples where that is going to be problematic. Okay, coming back to another dimension, kind of why we are talking about the hydrogen, why all that is important, is because, well, we need to make sure that our collective actions are much more aggressive in comparison to what the world is currently doing. So what I'm showing you here, so Tim mentioned that I was one of the lead authors on the assessment report 5. So this is the picture from the synthesis assessment report 6. So this is a picture which signed off by all policymakers from all countries which are participants in the IPCC. So somewhere is a signature from New Zealand, kind of which approved this particular picture. And so what it is showing is that while the current policies, well, that pink line is nowhere near where we need to be if we are serious about even 2-degree target, let alone 1.5-degree target. So it means that something has to happen in order to change that trajectory. And well, kind of another particular reason why I like putting this particular figure, you can take a look at 2019 emissions, the actual emissions in comparison to what is projected by IPCC. And even more, you can take a look at the kind of relationship between 2019 emissions, 2022, 2023 emissions. And typically, again, I'm from academic institution. If I will try to write a paper and where I'm going to show that, oh, my results, it's outside of the confidence interval, right? So those pink lines showing you 5 to 95% confidence interval. If I'll try to submit paper like that to any reasonable journal, that will be rejected. They will say, oh, well, how good you are. You are off out of your 5 to 95 percentile. Didn't stop any government, including your own government, right? Remember, somewhere is the signature of New Zealand government in this picture. So it means that whatever the projections, they're already off. So it means that whatever we need to do is even more than portrayed in this picture. So it means that those changes, those decisions which are going to be made, either going to be very, very aggressive in terms of the change in the energy mix, or, well, we might start questioning the goals or achievement of those goals. And again, I'll leave it up to you. That's not my job to tell you kind of to think where we are in terms of this strategy. But that's a very important component for any company or anybody who is making investment decision to understand which pathway we are on currently, because that is going to determine, well, what makes sense and what doesn't make economic sense. So if you really believe that we are going suddenly to change that globally and go to that blue line to 1.5, that's going to be one story. But, well, you can, again, I leave it to you to decide the realism of that. And so that means that, well, you are actually in charge of making sure that the economic decisions are made to keep the stability and productivity of the economy. And so it means that you have to make that judgment where the world is going to be, including where New Zealand is going to be in these trajectories, because a lot of things are going to be dependent on that. So how do we assess what is doable, how to quantify things? In addition to tell you the stories about kind of all this development, about all these technologies, we are trying to quantify. So we are trying to put the number behind that story, behind that nice story. And I'm going to show you later on a couple of the projections. But basically, we have a tool where we are trying to use that information and where we are looking for interlinkages between the countries, but also between different sectors of the economy. And so that model is called the EPA model. So the economic projections and policy analysis, well, typically we joke it's all seen in all dancing, right? So we are using that for many, many different applications. And you see, because it covers the whole economy, all economic sectors. So it means that whenever we are looking at, let's say, sustainable aviation fuel, or whenever we are looking at decarbonizing steel or cement industry, we have all these interlinkages, how things are going to be affected by different sectors. And also, because we are looking at the whole globe, well, we are looking also at things like, I don't know, CBAM, Border Carbon Adjustment Mechanism in the EU. Well, when they put that in place, what is the effect on the economies? Or if, well, who knows who is our next president, if he will decide again that he doesn't like all the tariffs with, let's say, China, and he will introduce new level of tariffs, well, we can put those new level of tariffs into the model and see what will be the implication for international trade. And so the underlying data covers, I think, 145 different countries and 65 different sectors. And so for particular studies, we can go much deeper in comparison to what is here in the standard model. But even more important, we are also taking into the look, well, the issues which are related to land use, to forestry, to other things, to biofuel. So it means that if I'm trying to put a big biofuel industry in the US, I will have a lot of other reactions, other impacts in different parts of the world, like Brazil, like Africa, like Southeast Asia. And so kind of that's the tool which we typically apply to do different studies. And sometimes we are applying that to understand what is the policy what are the policy implications, like that Inflation Reduction Act, which I have mentioned. We just done a study for U.S. Environmental Protection Agency to try to understand what is the impact of IRA. We also doing a lot of technology studies. So, well, we are doing, well, I promised that I'm not going to mention nuclear, but we are doing the study of fusion. Well, sometimes they'll say, oh, it's still nuclear. Well, it's a little bit different. But the point is at MIT, we have this startup, it's called Commonwealth Fusion, who are actually building one of these testing facility 50 miles north of MIT, where they're claiming that they are going to produce first prototype in a couple of years. And actually, well, there is a facility which actually building there. So what we are doing with this particular model, we are trying to understand and the different cost assumptions, a different involvement. Is there a role for fusion? How much difference that is going to make? Or, for example, we are doing study on something like direct air capture. So that's another thing. Again, if you're interested, we can go there. And so because you remember, we need to change that emission trajectory quite dramatic. And so we are trying to understand what is the role of different technologies in this story. So I'm going to refer to the EPA model results a little bit, but obviously I'm not going to be able to talk about all the things which we do with the EPA model. So if you are interested, here I put some of the publications, which are all of them in the public domain. And if you need to follow up or if you cannot locate them, well, let me know. These slides are going to be available. And if any follow-up questions, I'll be more than happy to elaborate. Since, well, we are at the Treasury, a couple of the studies, which I'm not going to go into detail, are related to climate-related financial risk. So we are working, for example, with Bank of Canada on trying to work on how to quantify the transition risk and what that means for financial stability of Canadian economy. Because, well, that's a job of Bank of Canada to make sure that everything is fine. And so we're also working with a couple of the investment companies, big long-term investment companies like Wellington Management, Amundi, Morgan Stanley, Fidelity, where they are trying to understand, okay, we are putting a lot of our money into these long-term investments. What is the transition risk? What is the physical risk? And so that's another avenue, which I'm not going to go into detail, but there are a couple of the publications, again, which are publicly available. I'll be more than happy to follow up on those. And where I'm going to go next is into our global change outlook. And so I'll show you at least our current view, where the world is going. And, well, what are the implications of where the world is going? And so that outlook, again, is publicly available. There are some Excel files which accompany that. They're also available. Unfortunately, we don't separate New Zealand as a separate region. It's kind of a little bit too small for us, but if needed, yeah, we obviously can go down there. So you actually, oh, I shouldn't even mention that we aggregate with Australia, and I know that's the cardinal sin, I think, but, well, that's what it is, at least in that presentation. But again, I refer you to Niño, who actually has a model of New Zealand with all the sectors and others. So if you're interested, he is expert in trying to project the economic impacts. So kind of to orient you a little bit where we are in terms of our scenarios and in terms of our views where the world is going. And the outlook is not that, well, we like where the world is going, but we are trying to understand and say, okay, if we are not going to change things, where we are going to be. And so first of all, I'm going to bring your attention to those three top lines. Those three top lines, these are the projections from, well, at least two reputable, if I'm not going to count myself as a reputable, but if we are going to talk about the International Energy Agency, that's their main scenario, which is called STEPS, so stated policy scenario. And that's their projections in terms of the emissions, global emissions, where the world is currently going. You remember I mentioned those IRA, Inflation Reduction Act. Well, we can talk about the European, like Repower EU. We can talk about many other things which are on books. Presumably your New Zealand emission trading system also in there. So, and you see that globally, well, yeah, that reduces emissions, but that's nowhere near where we need to be in order to be at net zero by 2050. And if we are going to take a look at the US Energy Information Administration projection, well, they're actually projecting that global emissions are going to go up, mostly to India, Africa, Southeast Asia, and kind of other things which are affecting that trajectory. You also can take a look at those kind of down below scenarios. So one of them is from something which is called net zero emissions, NZE, and kind of, well, again, typically when I'm presenting that in a closed setting like you, right? So just between me and you, well, typically I say, well, that net zero emission scenario, it's like Santa Claus. We love it, we enjoy it, but that's not real. Okay, so we want it to be real, but I don't think that's what we are going to see. And well, now I have to be much more careful with these public statements, because at some point I was joking about IEA projections, and then somebody from the audience said, oh, I'm going to see Fatih Birol, who is head of IEA, tomorrow in Istanbul. I'm going to pass your comments to him. I'm like, okay, it is what it is. So I'm now much more careful with or trying to be much more careful with the statements. But the point is, again, coming back to that original statement which I have made, well, we need to understand whenever we are making those policy prescriptions about the investments, about where the world is going, we need to make those decisions. And you need to make those decisions where we are, what are we prescribing. It's nice to be, don't get me wrong, I would be happy if we will be on that trajectory, but we are not there. And so it means that, well, you need to take that into consideration whenever you are trying to see where we're going. I'm going to go very, very briefly on the kind of results from the Outlook. Again, it's publicly available. It's very light read. It is intentionally done kind of to make sure that, well, we hope that regular person can read and understand. I'm not sure how good we are at that, and kind of trying to communicate to an informed person, but that's what's the intention. Because I want to leave a little bit more time to hydrogen. And so again, but hydrogen is going to be kind of important in order to understand kind of, well, where that development is going to lead based on what is our projection, where we think the world is going. And a couple of the things which you see here, this is global primary energy, and kind of no surprises, you will see that in many, many different outlooks, or much more low carbon sources, wind and solar, but well, see, it's not 100%. So kind of in our accelerated scenario, well, yeah, we are getting more and more, but we are not there. Also, the stories for different parts of the world are very, very different. And so what we have done for this, you remember that I showed you, well, all these different regions, 18 regions, well, for the purpose of the kind of visual presentation, here we have divided that into 3 categories. So advanced countries, so all the rich countries, including New Zealand, so that's the developed countries. Then we separated just 2 countries, India and China. So those 2 countries, and everything is on the same scale. So now you can see already the scale that those 2 countries are, well, comparable or even bigger than all developed countries, US, Europe, Japan, Korea, Canada. And so again, that brings the answer or question, well, if you are going to do a lot of things in Europe and US, how much global impact you are going to have? And so unless India and China are not on board and see a lot of blue colors, and that's coal. And again, that brings another story that the issues in different parts of the world are very, very different, right? The fuel is very different, which we need to replace. And so substitutability, availability of that fuel, of those fuels are also going to be important. But also take a look at the rest of the world. So if you are going to get out of the developed, India and China, so that's the picture for the rest of the world. And currently, the rest of the world do not have that many policies. And so we see that, well, we are projecting, well, substantial amount of natural gas and oil still in these economies. Well, the story is very different in the accelerated action scenario. But again, kind of the point is, well, that depends on a lot of assumptions, what is going to happen in places like Africa, I know, Kenya, or Burkina Faso, and all other places where we are going to expect what is going to happen in terms of the primary energy. Now, switching to electricity. So those pictures which I have showed you, those are the primary energy. So those are these are kind of the whole economy where they're getting the energy. So now I'm switching to electricity, and now you see a lot of green color, and this is wind and solar. And so it means that, well, yes, wind and solar are going to grow dramatically in any projection, and that is true. But even with all this growth, it's not going to replace all the fuel, because we still need fuels in other parts of the economy. And so this is where hydrogen is going to come again as a very important component. In terms of the climate implications, well, kind of our accelerated action is meeting 1.5 degree with some overshoot. So there is kind of categories in the IPCC reports. There are so-called C1, C2, C3. So C2 is reaching 50% probability 1.5 with, well, large overshoot, which defines as 0.1, 0.3 degrees above the target. So when you see in terms of the temperature, that's exactly what is happening. But in the current trends, well, you see that temperatures keep rising in all these extreme events, which, again, I'm not going to have time to go, and which we experience more and more, are going to rise. So it means that climate adaptation will be needed, will be necessary. Okay, hydrogen. Now let's switch gears and talk about hydrogen a little bit more in detail. I already mentioned you a couple of the colors. So a couple of things which I want you to take a look at. This graph are the costs. And so these are the costs per gigajoules. Well, that's comparable to like MMBTU or TCF. So kind of that's a typical cost of, let's say, natural gas. And any of you who are following natural gas prices, who can tell me what's the current natural gas price in the United States? Okay. Going once, going twice. Well, typical price of Henry Hub in the United States is about $5, 3, 4, 5. Well, it was much higher during kind of the peak of the Russia-Ukraine war. Well, it's still going on, but the prices went a little bit down. So $5 now compared to these numbers, well, that's already kind of not that attractive. And this is only production cost. Well, the current price actually at Henry Hub as of yesterday, $1.60. So it went down dramatically. The winter, well, global warming, the winter is very warm in the United States. Natural gas demand is not as high. The price actually went down. So, well, we will compare that again a little bit later. So the story is, if you're going to compare with the cost or projected cost for hydrogen, so these are the typical costs. And again, we can argue if it's $4 or $5 or $6, depending on location, depending on different assumptions. And again, obviously, if you have some areas where you have a lot of access to cheap renewables, like Chile would be a wonderful place. Australia would be a wonderful place because they have a lot of solar, a lot of wind. So that's probably the cheapest places to produce hydrogen in the world. And so you can see that, well, the projections, well, that they will go down over time. Well, there are many issues with those projections. Are they really going to go down over time? Because most of that is relying on the assumptions about the cost of electrolyzers. And most of the electrolyzers which we are going to use for green hydrogen needs to be variable. So actually, we know how to produce hydrogen for more than a century, right? The first green hydrogen was produced by alkaline electrolyzers long time ago. But those alkaline electrolyzers are not good at varying load. So it means that if we are talking about intermittent renewables, we need something else. We need so-called PEM electrolyzers. And so that's what is driving that cost. And so the idea, with more experience, that cost may go down. May or may not, who knows? But that's kind of the main projection. Well, but that's only part of the story. And I particularly like this diagram, which is actually from 2002, to more than 20 years ago. In terms of the cost, not much has changed. So if you're going to take a look at the current estimates of production of hydrogen and current estimates of transportation of hydrogen, well, it's not that different from that diagram from 2002. So not much learning has been doing between these 20 years. But another point is the transportation cost is even bigger or comparable. So whenever somebody is telling you, oh, the cost of producing hydrogen is $2 or $3 or whatever, well, multiply that at least by 2. because that is going to be the real cost of hydrogen. And just to give you one kind of evidence in terms of the costs, which actually even worse than that, but again, there are many issues why you cannot really make that direct comparison. So I have told you that steam methane reforming production of a hydrogen, the cost is about $1 per kilogram, $1.50. If you're going to try and see and go to California, and if you are lucky or unlucky to have one of those hydrogen cars and try to see what is the cost of hydrogen at that hydrogen station, well, you will see that the cost is not $1, not $2. The cost is more than $10. So that's the real cost. That's what the companies are saying, what it would take to bring that hydrogen to the pump. And so already kind of, oh, well, something is not really comparable with all other costs. And so this diagram is actually giving you even kind of better understanding where we are in terms of the cost and why I have made that statement that hydrogen is an expensive fuel. So if we are talking about $2 per kilogram, if I'm going to convert what would be the equivalent price of natural gas at that $2, you see that that's about $18 per MMBTU. And I just told you, what's the price of natural gas in the United States? Less than $2. Less than $2, right? So now you're an industrial user and you're making your economic decision. Should I pay $2 for my gas or $20 for my gas? Well, you don't need a PhD in economics, right? So to calculate what they are going to decide. And I'm giving you very favorable number for the cost of hydrogen. The current number, you remember, $10, right? So, well, multiply by that, right? And kind of you get what is the current cost and how it's compared with cost of natural gas. So again, in terms of the emissions, that's great. If you are going to go green hydrogen, in terms of the cost, well, that's going to be a very expensive solution. It means, well, either hydrogen needs a lot of government support, and if you have a rich country like the United States who decided, okay, we are going to spend, well, by the estimates of Congressional Budget Office, about $1 trillion on the Inflation Reduction Act, well, they're free to do that. But if you are talking to government, I don't know, I had a conversation with Minister of Finance of Brazil where they are trying to kind of also push that. He said, no, we are not going to give a single penny to those hydrogen producers because we have many other issues which we need to resolve. So again, good. It's a solution to many, many parts of the economy, but it also has its own challenges. Another diagram which I found very, very useful, and that also explained kind of, well, what is the story behind hydrogen? It also explained what is the story behind the competing technology, which is carbon capture. And again, I'm not sure what is the attitude in New Zealand about carbon capture, so I'm guessing also not so positive, but well, you can correct me if I'm wrong about that. But the point is, well, take a look at these bars. And kind of, you don't really need to look at the numbers, but kind of visualize them. So the bars which are in gray, these are the current cost of producing things like steel, cement, or chemicals. Well, if you want to deploy CCS, and sometimes we are getting that question, oh, why we are not seeing some CCS? Well, the reason is very simple. And kind of, you can flip that question around. I can tell you that we are going to be serious at reaching those dramatic emission reductions when we will see a lot of CCS. And if we are not seeing, means that we are not going to go to those dramatic emission reductions. Because, well, you need more energy, you need more capital in order to install CCS. So it means that the product with carbon capture is always going to be more expensive. But now compare with hydrogen, those purple bars. This is the cost of producing the same thing with hydrogen. That's even more expensive. So again, coming back, yes, technologically it's doable. We can do that with hydrogen. But then, well, guys like you from Treasury, Ministry of Finance, or Central Bank will say, oh, do we really have money to support that? Because ultimately, that's what would be needed in order to bring that fuel into the system. So similarly, so we have recently published the paper where we compared the cost of doing steelmaking. And I think you have, what, one steel-making steel mill in New Zealand, and again, correct me if I'm wrong. And again, you're doing that in different way than the rest of the world, and kind of that's not really applicable that much to you. But the point is, again, if you go to alternative ways of doing steel making, like CCS or hydrogen, you see the cost when we are deploying the green hydrogen. And it means that, yeah, if you're in Sweden, if you're hybrid and you're saying, okay, well, we have green steel out of hydrogen. Yes, they do. They pre-sold all the output of their new steel mill, which they haven't built yet. But the cost of that steel is 3 times more expensive. So it means that if they're going to build a car out of that steel, I will have to pay much more. Or I'll have to pay much more for that house which they're going to build using that steel. And well, yeah, for PR purposes to say, oh, we are doing something, that's great. But can you really move the whole economy to be twice as expensive? Well, again, I'll leave the answer to that question to you. So another point where actually closer to kind of your home, kind of, if we are going to take a look at the structure of the emissions here in New Zealand, well, I'm not going to touch the agriculture and dairy and kind of other things, because that's not CO2, that's methane, and that's a different story. So, but yeah, we can go there if needed. Just a second, I'll finish this and I'll get to that question. And thank you for raising question. Finally, somebody was brave enough to ask something. But the point is, take a look at that comparison. I really love this diagram from the US government. So that's a like national blueprint for decarbonizing transportation. And it visualizes very well where different fuel fit to decarbonizing. And so take a look at the hydrogen. And if you're going to take a look at light duty vehicles, well, they have 0. So they gave up. So basically the story for fuel cell electric vehicles, according to this diagram, it's gone, it's lost. So they lost this race to electric cars. They lost this. And so it means that, well, if we are going to take a look at the fleet composition here in New Zealand, again, somewhat strange. You don't really have that much heavy duty vehicles. A lot of your fleet is light duty. So it means that hydrogen is not a solution for that. So it means that if you want to decarbonize transportation in New Zealand, well, you see what are the preferred ways of doing that. But New Zealand has a lot of international air traffic, a lot of shipping, and then the story is slightly different. And now I'm going to pause and go to that and then to this. Yeah, please. I think she wants to use it to mic because of the screen thing.
I just wanted to see if you were seeing any sign of addressing the externalized costs of fossil fuels and thinking about how that changes the costs.
That's a great question. And so that's a typical economic question, right? So I showed you those bars. This is the cost of typical way. This is more expensive, but more environmentally friendly way. Definitely economically, nobody is going to choose more expensive. So we need to change that. Well, one way to change is kind of make it cheaper to do a lot of research and development and reduce the cost of the alternative. But there is an alternative way, make the usual way more expensive. And so that's what probably you're referring, how to make sure that we are reflecting full cost of environmental impacts. So again, you have emission trading scheme, right? So, well, you can do carbon taxes, whatever name you can pass politically, because in the US, you cannot do carbon taxes, right? So that's forbidden. But whatever you can do in order to make that more expensive, well, that's another way how to get there. So coming back to your question, in some places, yes, kind of we're seeing more and more of that. But in many places, if you're going to take a look at the map and take a look at the current level of carbon pricing, well, you will see that, well, New Zealand, what, it's 70 New Zealand dollars, right? So current ETS price, so it's what, 45 US dollars. So kind of the European, somewhat sizable. And well, there are a couple more examples, and that's it. Kind of the rest of the world is not pricing that carbon. If you're going to take a look at China prices for ETS, they're very, very low, and it's on a very limited segment. And everywhere else, it's like $1, $2. Well, that's not real. So yes, in theory, in principle, that's the right way to do. And again, kind of New Zealand has all the right instruments. Again, you're in somewhat different situation than the rest of the world, so you have much more difficult job in many places. But that's one avenue, or at least economic way of doing things, because that's where you are not really regulating something, but where you sending clear economic signal what to do. But as you know, politically, that's not as easy. I think she wants the mic.
Dobry Dean, Sergey, I've noticed you've introduced fuel cells. Now, is there any reason, which I presume are producing electricity to drive electric motors, is there any reason why, if that's the case, that hydrogen would be used this way instead of an internal combustion engine burning hydrogen?
Yes, so again, the hydrogen store, there are a couple of things. Yes, you can burn hydrogen in internal combustion agent. You can burn hydrogen even to produce electricity. There are certain things which you need to do with your engine or motor or turbine, but in principle, it's doable. Same issues which are affecting the fuel cell. The fuel cell is even more challenging, right? Because you're starting with producing hydrogen, then converting that to electricity, and then electricity is driving your wheels. While electric cars is you already start with electricity and drive. So the efficiency is better for electric cars always. But the main issue with hydrogen, especially for light duty, is infrastructure. The cars are also expensive, but at least if you're going to take a look at the price tag of Toyota Mirai, well, it's cheaper than Tesla Model S. So it's but the infrastructure is where major cost and where the major imperfection of the hydrogen system. So one may say that, well, this is the snapshot right now and maybe in the near future, but at least hypothetically, at least for the US, the story for hydrogen cars might be different, because if the heavy duty segment will go one way or another, and this is where too early to call which way it's going to go. Because if you're going to take a look at Elon Musk Tesla Semi, it's not delivering as promised yet. While hydrogen diesel truck or hydrogen trucks also not there yet, but it's not clear how that is going to evolve. But if that is going to build infrastructure, hydrogen fueling infrastructure, then that is going to make the case for any type of the hydrogen cars much easier. And again, if we are going to take a look at the comparison of different pathways and liquid hydrogen or gaseous hydrogen, probably since you're asking that question, you're very well aware that 2-3 years ago, at least in shipping industry, it was a lot of enthusiasm about the liquid hydrogen. And actually, it was one of the projects in Norway which we were trying to build in production of hydrogen in order to power at least the domestic travel shipping in Norway. And they canceled that. And again, the question is the cost is not comparable to that. So there are still the biggest issue with hydrogen is infrastructure. Somebody has it.
I was just going to ask a follow-up question. It's interesting to see that hydrogen's not winning out in this chart, although the recent experience with a lot of automakers pulling back from their quite ambitious plans for electric vehicles, and you still continue to see Toyota talk up the merits of hydrogen, and it still remains deeply committed to hydrogen as eventually winning that, and they're one of the largest car, if not the largest car manufacturer in the world. What is it that we're missing? Well, how are they thinking about this, given I think you've very clearly said the challenges are going to be on the distribution side? So can you talk a little bit about how you see the economies of scale coming down and that, maybe adding on to your points?
So that's an interesting point. And we know Toyota guys very well. In fact, I'm having a meeting with them next week. They are coming exactly on that point, because they are one of the few companies which haven't given up on hydrogen. There is also the Koreans like Hyundai. And so those are the two countries, not surprisingly, who are still looking very heavily on hydrogen. And maybe the story for New Zealand is somewhat similar. And the reason is very simple, is, well, those two countries are imported all of their fossil fuels. And as a result, most of the electricity costs are much higher than in many other places. And so the calculation for them, including kind of the issues related to energy security and other things, is somewhat different than calculation for the United States or calculation for Europe. So the point is, it might be a couple of the cases for particular countries where indeed that still is going to make sense, but I would need to explore much more kind of what are the alternatives and other things which are happening here. And somebody can tell me, well, you just closed your refinery, right? So a couple of years ago. I don't know what's the long-term implications kind of on the domestic fuel prices. Are they went up or are you still getting the same and how are things? So a lot of other things which are going to affect the decision-making at a particular level. But yes, you're right. Toyota and Hyundai, kind of those are the two companies which are still trying to push the fuel cell vehicles as much as possible. Somebody else got a question.
Hi, I'm wanting to know a little bit more about the Inflation Reduction Act and how well those subsidies are being targeted towards infrastructure and overcoming some of these high costs, or where's the subsidies being directed?
So Inflation Reduction Act is a quite complicated piece of legislation. Well, that's another interesting observations about the policies. And I can give you another example of another policy where I love to bring typically. So because, well, we're in this business, well, I've been doing that for almost a quarter of a century. If you ask me half a year before the act actually was signed, I would say, well, nothing like that is going to appear, right? So nobody predicted that that is actually going to be legislation in the United States. So that's one point. Another point, it has a lot of provisions where it's left actually to the Treasury, to the U.S. Treasury, to determine them because it's a tax, right? So it's a tax credits. So it's up to the Treasury to define. And so actually, we are doing a big study for the Department of Energy with National Petroleum Council in the U.S. exactly on that point. What is the future of hydrogen, kind of in production and consumption in different parts? And well, we almost done with the study, but well, I think 2 weeks ago, finally the Treasury came up with recommendations like how, you remember I told you $3 for green hydrogen, 60 cents for this, how exactly that is, because it's a lot of issues. We are talking about intermittency, how that is going to be counted. Is it like 1 for 1? Is it synchronous, asynchronous? So how kind of a lot of details which were not specified and still not specified. And they come up with these new proposals, which makes the blue hydrogen much less attractive. And so, again, that means that, well, there is a story about the technology, there is a story about the economics, but there is a big story about regulations, right? And so coming back to your question, well, I showed you the typical cost of production, and it's $3, $4. Right, add transportation, well, we are talking about, well, at best like $4, $5. The subsidy is $3. So it means that still kind of somewhere, well, it's not fully covering even that kind of on the best scenario, the hydrogen. But Inflation Reduction Act is not just about hydrogen. There is something which is called 45Q. This is carbon capture and storage, right? So they're giving $85 per ton of CO2 if you capture that and store. They're giving $60 per ton of CO2 if you capture that and use it in the product, like enhanced oil recovery, for example. Well, which defeats the purpose, but well, that's what they do. They give you $180 for direct air capture. Well, nobody is going to make money on that one because you can actually buy the credits from direct air capture plant. There's only one in the world. Only one in Iceland. You can go on website and buy your credit. So I can go and buy credit to offset that flight from Boston to Wellington, but well, we'll see. So, but the point is, you can buy it at $1,400 per ton of CO2. That's the real cost of direct air capture as of today. So, but there are many, many other things. And again, coming back to infrastructure, most of the infrastructure is for electric cars, electric chargers, kind of, well, there is certain things for domestic production of batteries, recycling, other things, which is changing the landscape quite dramatically in the United States. If you're going to take a look at where the projects are, And you remember, well, in the United States, we have these two parties, right? Democratic, Republican, right? And Republicans have certain attitudes towards certain things. But if you're going to take a look where the projects are, there are a lot of them in those Republican states. So, well, business is business, right? Once you give them the right incentive, they will do that. So coming back to your story, it's a mixed bag. So it's again too early to see how things are going to evolve, but it's sizable amount of money which is going to be at stake. But then the U.S. government is doing a lot of other things. So U.S. Department of Energy has these hydrogen hubs, like 7 hydrogen hubs, each $1 billion. There is another hydrogen hub on demand side. So it's already $8 billion to jumpstart in different places. And again, yeah, it's great if you have deep pockets, right? And you can afford billions and billions on those things. What will be the outcome? Definitely it will be projects, so for sure. But is it going to be at the scale which is needed? Well, it's too early to say. Yes.
Kia Sergey. It seems to me that as we increase our drive to renewables, it's going to involve an awful lot of infrastructure building and therefore an awful lot of energy. Therefore, in the short term, our emissions are likely to increase dramatically. And I'm just wondering, are we in a real catch-22 where the only real solution to all this is actually to dramatically reduce our energy requirements?
That's a fantastic question. And indeed, well, I can give you a very simple example. And I don't know, for some reason, reporters love asking questions about electric cars. And so at some point we have done a study on electric cars. So like almost every month I get a question from yet another newspaper or TV program about electric cars. And I'm not sure if you're kind of in that circle, but in the US, recently on Facebook and Twitter, it was a lot of posts where they will show you the battery from Tesla, battery park from Tesla underneath the car, right? And then they'll say you, oh, this many tons of cobalt you need to do, this many tons of lithium, and you need to bring that. And those big trucks which are doing that are using these many liters of diesel. And kind of when you pack that back in the electric car and you have zero emission vehicle. And like the question is, well, what's the story? So kind of one part of that is true, that production of alternative fuels may increase the emissions. So typically, if you want to produce electric car, and if you're going to compare that internal combustion car, well, typically the emissions are growing by 50 to 100%. So it means that production of the car is definitely more emission intensive. But if you're going to take a look at the full life cycle, because, well, once you start driving, if you have a clean electricity like in Norway, or clean electricity like here, or relatively clean electricity like here, you are immediately more than offsetting the emissions, the tailpipe emissions, which you have in internal combustion vehicle. So similar story with all other things. And kind of not sure how we're doing on time. Definitely, I'm not going to finish the whole presentation. But that's one of the calculations which we are also doing with hydrogen. And that's a very simple calculation. At some point, we have a project with the government of Norway, with their Ministry of Energy, where they were obviously interested. Oh, Europe needs hydrogen. We can deliver. Well, we can deliver that because we have a lot of natural gas, right? We can produce that out of natural gas, ship it to Germany. Well, Germany can capture, or we can capture it domestically. And if Germany is capturing, they're shipping CO2 back to us. So that's a great business. Or, well, all of our electricity is hydro-based. So Norway is almost fully hydro-powered. And so it means that, well, we can produce that green hydrogen out of hydropower. Well, we can ship that green hydrogen and kind of voila. When we start calculating, if Germany wants to replace its industrial gas use, natural gas, and convert all that natural gas to green hydrogen, how much electricity in terms of wind and solar is needed to produce that green hydrogen? And the answer is 3 times more than their current electricity consumption. This morning, I have done similar calculation for New Zealand. And, well, I took the publicly available information about your final consumption, about your primary energy consumption. And if IEA is not fooling me with their numbers, well, the amount of natural gas which is used in the final consumption, it's about 0.1 exajoules. Give it or take, well, depending on the year. I can calculate the efficiency of electrolyzers, how much electricity do I need to use in order to produce 1 million ton or 1 kilogram of hydrogen. And I can calculate how much wind and solar I need to install in order to replace all the current natural gas use in New Zealand. And the answer is 45 terawatt hours. And those of you who are familiar with numbers, that's the total electricity production and consumption in New Zealand. So that gives you another understanding in terms of the scale, right? Okay, we are just replacing 20% of our energy, or 17% to be precise, and we have to build another electricity production sector. And so that means new power lines, that means new grid, that means a lot of other things. So kind of that's a big question when we are talking about these scalable solutions like hydrogen, well, to calculate what are the implications for many, many other things. But again, in terms of the emission reduction, that makes perfect sense. So, well, don't get me wrong, but it's up to organizations like you, right, who will go to the government and say, oh, wait a minute, oh, how much that is going to cost us? But that's your question and your answer, not mine. I'm from academic institution. I can blabber about whatever I want, right? Okay. Okay, let's try to at least get our remaining slides very, very quickly, and then we will go to Q&A. So as I have mentioned, yeah, so private light-duty vehicles, well, probably that's not really a solution for hydrogen, except for some of the cases. Well, sustainable aviation fuels. So that's another sizeable area where hydrogen is going to provide a solution. And currently we are doing a couple studies, well, one with Federal Aviation Administration, another with Airbus and LATAM Airlines, where we are trying to understand, well, what are the pathways to decarbonize aviation in Latin America? And so these simplified diagrams shows you that, well, even though something which is called SAF, sustainable aviation fuel, it's exactly the same fuel, exactly the same classification, what you are going to put into your airplane. And it's very, very difficult to change that because, well, airplanes are there for a long, long time, some of them 20, 25 years. So it means that whatever airplane Air New Zealand is getting now, well, they're going to fly that in 2050. So it means that whatever the solutions have to be in the fuel, not in the airplane. Well, Airbus also is working on hydrogen planes and other things, but that's much long distance future. But the point is, well, some of these pathways are not good enough. So if you're going to take a look at the HEFA production, and if you are going to compare that with ethanol production in the US from corn, in terms of the emissions, if you're going to compare emissions per unit of the energy, well, it's no gain. So you can convert all the jet fuel in the US on corn-based ethanol, sustainable aviation fuel, and you will have zero emission reduction. So the point is, the only holy grail, and you see some of these blue lines, the only holy grail is so-called power to liquids. And so power to liquids where you need hydrogen, but also you need carbon. And hydrogen we already discussed. Well, we can produce green hydrogen and low carbon hydrogen, but surprisingly enough, it's not that much low carbon available because, well, this is where you're getting either from either direct air capture or particular biofuel pathways. And so somebody has made a calculation. I've seen it on one of the websites, one of your ministries. Excuse me if I go and not mention them correctly, Ministry of Business, something and something, right? BI. So I love their comparison. So they have done that calculation. If I'm going to fly from Auckland to Christchurch, and if I'm going to substitute that 4 tons of jet fuel, which you need in order to fly airplane from Auckland to Christchurch with sustainable aviation fuel. And they have done that calculation based on HEFA. That's the cheapest possible way. They calculated how many dead pigs do you need in order to convert that fat into sustainable aviation fuel. And each flight requires about 1,000 pigs. So, well, you can calculate, well, how many flights per year Air New Zealand is doing, and how many pigs do you need in order to fuel that sustainable aviation fuels. Again, there are many, many different pathways, don't get me wrong, but again, coming back to the scale and kind of what is needed in order to achieve those targets. But that's another point. Well, another point closer to you is shipping, right? And again, we are out of time, but definitely we can talk about the liquid hydrogen. I already mentioned that, well, it was some of the projects which were canceled recently, but also obviously methanol. So Maersk is making big bet on methanol. And so they already have a couple ships. So, well, they're kind of going with methanol. And the good thing about New Zealand, again, correct me if I'm wrong, you have at least 3 methanol production plants here in this country, right? So kind of you have also your own natural gas production, which you're trying to get rid of. So, but the point is, again, that's another fuel which might be a solution. But methanol still, if you're going to take a look at the chemical formula of methanol, it still has C, it still has carbon. So it means that's not going to be a long-term solution. Yeah, you can produce methanol with many green pathways, but still it's going to have carbon when you burn it. And so another option is ammonia, right? NH3, no carbon. Oh, great. So we can go that way. But again, there are many issues which are related to ammonia ship, right? And there is a very interesting story. One rich Australian iron and ore mogul, he was trying to ship on the ammonia-based vessel to COP28 to Dubai from Singapore. And so he built and he was spent a lot of money on that vessel and kind of, well, he ended up using diesel in order to go from Singapore to Dubai. Well, again, there are many, many reasons why, but kind of we don't really have dual stroke engine which handles ammonia yet. Well, a lot of companies are working on that. And again, that's going to be another very tough to decarbonize sector. But since you are so dependent on international trade, and so all that dairy, all those fruits, all other things which you are sending to the rest of the world, at some point people will start asking, oh, but how you're powering kind of all those shipments? And so it means that, well, you will also need to think about that. Well, you remember that policy story which I advertised, so kind of I'll go there and probably I'll skip kind of rest of the story, otherwise I'll keep you for the next 3 hours here. So policy story. In 2007, it was a different president in the United States, George Bush Jr. He signed something into the law which is called Energy Independence and Security Act. Energy Independence and Security Act of 2007. That law, it's fully signed, fully approved by the Congress, required to produce certain amount of biofuel. So at that point, they were trying to push big biofuel industry. It was a requirement to produce in 2022 about 20 billion gallons of second generation biofuels. So that second generation, which doesn't compete with food, right? So kind of you're doing that lignocellulosic. So that was requirement in the law, kind of year by year, how much you need to produce. I know for sure a lot of investors who said, oh, that's a requirement. It means that that's good for our technology. We will invest a lot of money to produce second generation biofuels because the US government is going to buy that anyway, because that's a mandate. Well, another quiz for you. Again, I'm from academic institution. I love to ask questions, especially if I know the answer. So the question is, how much second generation biofuels were produced in the United States in 2022? And the right answer is 0. So, well, that gives you also, well, whatever the legislation, well, be careful. Whatever the investment you're trying to rely on, be careful, because even if it's legally mandated, if technology is not there, if economics is not there, well, you need to be careful about that. Well, why the irony of that and why kind of I'm connecting that to shipping? Well, currently, if you're going to take a look at the soybean oil production in the United States, half of that oil goes to California. Why? Because they have renewable diesel requirement. So if you're going to take a look at the HEFA prices, and that's the cheapest way kind of for sustainable aviation fuel, you will see that currently prices 2-3 times higher than they were before. And the reason is California, because they have a mandate. The irony, none of that is produced in California. And the irony, substantial part is coming from Singapore. Great renewable policy, which is going to reduce emissions in California, where you're producing that fuel in Singapore, shipping that all the way to California. Again, so I don't need to elaborate more than that. So a lot of things, back to the question, kind of which requires very careful thinking to make sure that you are avoiding all these unintended consequences. So very, very briefly, just again, the slides are going to be available publicly just to make sure that you are seeing all the stories. That's exactly the exercise which we have done for Norway and Germany, which I described earlier, kind of which tells that, well, it's going to be a lot of new. The hydrogen demand, this is directly from IEA. So you can also take a look at where IEA, International Energy Agency, is projecting where it's going to be. And kind of you take a look at different parts of the world, and obviously US and China. And so kind of there are different drivers, what is driving that. But even with all that, it's not going to replace all the fuel. So at best, it's less than 10% of final energy, even less than that, even in most aggressive scenarios. So yes, there is a place for hydrogen. There is, it's not, you don't need to discard that completely. And most of the hydrogen, at least in the US, and again, I'm less familiar with kind of what is the story here. And it looks like you are successfully trying to eliminate all the industry in New Zealand anyway. So, but in the US, most of the use for hydrogen is in industrial sector. So kind of fertilizer production, kind of other things, chemicals, that's where hydrogen makes sense. And this is where hydrogen is going. And kind of, I want to close with a couple final notes. Well, don't rely on any particular solution. We don't have a silver bullet. So it means that we need to take a look at a lot of actions. And kind of the story, we need to make sure that we have a good expertise. So if next time you're going to have a different speaker from MIT, and again, MIT is a very diverse institution. We have a lot of hydrogen proponents, and maybe different speaker from MIT will tell you hydrogen is going to solve all of the issues. You need to develop that expertise to make sure you make those decisions. And unfortunately, it's not going to be just about one fuel. It's going to be a lot of different pathways, both on the technology side, but also on the demand side. So it means that we wouldn't be able to solve this issue if there is no customer response, if there is no consumer response. And it means that you would need to think very, very deeply how to make sure that everybody is engaged with that. But again, no matter what, we know that we have to solve this problem. We know that if we are not going to solve, well, if you really care about your kids or grandchildren on other kind of generations, we need to change that. And so whatever you're thinking, whatever you're supporting, again, don't get me wrong, we will have a lot of challenges. It's not the easy solution. Otherwise, we have been solved that a long time ago. But well, with all the efforts, we still haven't found a solution. So it means that despite all the challenges which I have described here, the next solution which you are making, keep that in mind. Is it going to reduce emissions or not? Because that's extremely important. Because that's extremely important not only for you, but for the next generations and others and others. And hopefully, at some point, we will arrive at this solution over here. So I'll stop right here. Thank you very much. And I think we still have some time for Q&A. Not much, but some.
Well, thank you very much, Sergey. That was fascinating. Now I've just seen the camera swing towards us, so we're both visible online too. That was a fascinating talk. Clearly a lot of complexity, the different pathways, the different technologies, all moving at the same time. What I might do is go to the online questions first, because we've had a good chance in the room to ask some questions. You can feel free if we have time. Actually, we probably won't. But let me go to the online questions. I'm going to pick the ones that I think haven't been covered so much yet by the questions already. So do forgive me for those online if I don't get to your question, but I'll do my best to cover in terms of topics. So the first question, I think, which is quite interesting, comes from Jez. And Jez says, hydrogen is losing every technology battle where any other solution exists. Batteries have won light vehicles. The UK experiment in hydrogen for home heating has only shown how uncompetitive hydrogen is against electricity and heat pumps. The costs for hydrogen are inherently too high because of the terrible end-to-end efficiency. So which uses for hydrogen have no alternatives?
Yeah, so that's actually a very good question, and I think I alluded on that in that study for Department of Energy. That's one of the main kind of focuses where in the economy hydrogen makes most of the sense. And as I have described, most of the sense it makes in the industry. So high heat requirements, chemicals, fertilizer production, ammonia production. So this is where hydrogen makes a lot of sense. You mentioned residential, commercial. Well, kind of you don't need to do a very kind of deep calculation to understand that that's not a good solution. Similarly, we already discussed the private transportation, but heavy duty, we don't know. So again, battery still not delivering. Battery too heavy, not kind of providing good range. In addition, you're losing a lot of cargo. So like in the US, for example, we have a limit how much the truck is going to weigh. So you cannot have kind of above the certain limit. And now you can compare the diesel truck with battery electric truck. And if the battery is heavy, well, it means that you are losing a lot of useful cargo. So it means that with the same weight of the overall weight of a truck, suddenly you're much less profitable. So it's not about only the cost, it's a lot of other things which are related to that. So hydrogen kind of at least eliminates or kind of reduces that issue. So it's not clear on the heavy duty what is going to be the clear winner. So I would say clear winner, well, on light duty, we know the electric, but over there, so industry and heavy duty, those are two main. And shipping, so hydrogen-based fuel, so not liquid hydrogen, but like ammonia, methanol in shipping, that makes sense.
Very interesting, thanks. I think it's a related question. So for those applications where it's hard to think of where hydrogen technically is a competitor, how high do you think the price, the ballpark, how high would the price of carbon have to be to make some of those applications start to become commercially viable at scale?
I'm smiling because, well, in our program, we are doing these projections. And if you're going to take a look at our outlook, we are making projections for oil prices, gas prices, carbon prices, and many other things. But let me tell you a short story. We have a very prominent professor at our economics department. His name is Robert Pindyke. And he is very big expert in statistical methods, econometrics, but also projections. And so once we had a very good conversation with him, and he said, Sergey, if you are trying to predict the price for the next half year or for the next year, you either fooling yourself or you're fooling your public. So which one of that you are doing? So, and he's very, very good at that. And so the point is, it's so many things which are going to be affected not just by technologies, but all the things which we discussed here. I can kind of give you some indication in terms of the technology, but then I know New Zealand will decide, oh, we will have something like Inflation Reduction Act, and somewhere you will find, I know, that $1 trillion somewhere in your pockets, right, to spend. And all that is going to change that calculation very, very dramatically. So the point is, yes, we need high sustained carbon prices, again, coming back to that original question, to make sure that the fuels are competing. But what is the exact number at this point? Well, sometimes I'm brave and I'm providing those numbers, but not today.
All right, thanks. I'll do one more from online, and then I'll give the room a chance for one more question, and then I think we should wrap up. But the question is, it's New Zealand specific. Our electricity, but it actually applies to other electricity systems as well, I think. The question is from Carl. New Zealand's electricity system experiences prolonged episodes of low hydro inflows, rainfall inflows every few years. So it needs a large source of controllable generation for demand response that can be sustained for 8 to 12 weeks at a time. What is your view about the suitability of hydrogen for filling that gap?
Well, again, technically it's possible. So there are a couple of turbines which are dual fuel, and there are a couple of the plants in the United States where currently co-firing is done. And so it means that turbine can take both natural gas and hydrogen. In principle, kind of you can do that. The first question is, well, where that hydrogen in New Zealand is going to come from. You remember that calculation which I gave you. So if you want to replace how much wind and solar you need to install. And my understanding that, well, wind is still a very small part of that. So geothermal also has certain issues. And kind of coming back to the question which was asked, indeed, well, what is the backup where you have very low year in terms of the hydro generation? So again, technically, yes, it is. It can be. And my understanding, currently you have one coal power plant, right, which is doing that business, and it's dual fuel, right? You can go coal or natural gas. But since you're trying to eliminate both coal and natural gas, well, that plant in principle can run on hydrogen with some additional things in terms of the firing capacity. So it might be the answer. The question is the cost, right? So if New Zealand is willing to pay that cost to decarbonize and making sure that you are providing stable electricity, technically it's done. So the EPA, the US Environmental Protection Agency, is actually trying to create the requirements, again, trying to solve the issue because most of the coal generation is going down in the US, but now it's a lot of natural gas generation. And so the next question for EPA is, well, how to reduce emissions from that? And so they are providing the requirements that either you would have to install CCS, carbon capture, on those natural gas plants, or you would do co-firing of hydrogen. So kind of, again, there is a push into that direction. So if the decision is made here in New Zealand, what to do with those plants which needs to balance the load, technically it's doable.
Thank you, Sergey. So one more question, and over here, Anna, please.
Thank you. I was just wondering about what the major differences are between the development of the hydrogen industry now and what we would have faced putting together, the liquid natural gas industry back in the day. Like, what's the major barrier here?
You mean LNG?
Yeah.
Well, so natural gas, in terms of the infrastructure, in terms of the pipelines, in terms of other things, has been with us for a long, long time. And again, speaking of New Zealand, you're again somewhat in unique situation, right? So you're actually not importing any LNG, or very little to my knowledge. Most of the natural gas is domestic, right? So as a result, all those high prices has nothing to do with you. It's determined by different dynamics, what is the cost of natural gas here in New Zealand. But still, you have a lot of infrastructure which is already there. If we are talking about the hydrogen and hydrogen infrastructure, so the pipelines, most of the pipelines are not suitable for hydrogen because there is so-called embrittlement. And so these existing pipelines can take some portion of hydrogen, but that doesn't make much sense unless you convert that. Again, you can kind of redo those pipelines, and there are certain technologies. And actually, I know one of the companies with which we are working, the electricity distribution, natural gas distribution company, have done that study, or what it would take if we will convert all our natural gas pipelines into hydrogen-ready pipelines. That's a lot of money. And so, again, unfortunately, I'm going to give you the same answer. Technologically, it's doable, but that is going to cost a lot of money. And so The problem with hydrogen is you also need to kind of take a look at what are the competitors, right? So the natural gas infrastructure is already there. And kind of more importantly, with LNG, a lot of that was driven by kind of perceived very, very high demand for natural gas. So if you're going to take a look at 10 years ago at IEA, their projections were golden age of natural gas, right? Or something like that. Everybody was thinking, oh, we are going big time to natural gas. And so a lot of projects in Australia was driven by that. Now the new wave of the projects in the US is driven by that low natural gas price in the US. And remember, I told you it's less than $2. Well, you can make a lot of money, right, by selling and liquefying that. So, but kind of technologically, yeah, you need to build infrastructure for kind of liquefying, shipping. Well, and then the question is, okay, building those tankers, building those things, how to move it from one place to another. And so if that's the biggest issue.
All right, thanks very much. We have unfortunately run out of time, but you can see, everyone can see from all the questions and so on that it's been a fascinating presentation, Sergey. Thank you very much for sharing your expertise and time with us. Many thanks again to our colleagues from Motu Research for a great collaboration on this event and for connecting us with Sergey. It's really great to see a New Zealand connection to such great work and research being done internationally. Thanks to everyone here for coming along in person and for all the questions, and thanks to those online who participated virtually. Please keep an eye out, everyone, for upcoming seminars in this series. There are more to come, and we will advertise them through the usual channels. You can sign up by email to be alerted for those events coming up. I do recommend them to you. The next one I see here is taking place on the 7th of March, although it doesn't say what it is. So I'm sorry about that. I escaped my attention exactly what that one is, but it is on the 7th of March. So let me now finish with a proverb, a whakatauki. Mata korero ka mohio, mata mohio ka marama, mata marama ka mātou, mata mātou ka ora te iwi. And that one says that with discussion comes learning, with learning comes understanding, with understanding comes knowledge, and with knowledge comes the well-being of the people. Thanks once again to everyone for attending, and especially to Sergey for presenting and taking questions in such a fascinating discussion. Matua.